First in the project, one must make himself comfortable with his goals. In this case, the goal is to replace my old, cheapest Growlight ever, otherwise known as the 5-buck Growlight, link in the upper right hand corner now, with a new fangled full spectrum one. And the overall budget for this one is now 5 times higher with a total price of 25 euros. And for that you get the following parts, starting with the heatsink. This is from a Dell Optiplex. Then the LED, it's a 20-watt grow light. Then a few 3D printed parts, including the holding bracket, which is a flexure. I'm quite happy with that. Then a few nuts and bolts, the LED driver, and finally a fan. You can find the detailed parts list in the description below. So this is not my first rodeo in building LED cop lights. And I'm trying to use as many parts as possible from the previous build, but unfortunately, due to using an LED cop with an external driver this time, I need to redesign the main case. And so you can see me here now taking measurements of all the parts that will go into that case. I also designed my old lamp in Fusion, and so I'm just picking up the old design and adjusting that to fit the new LED driver, and I'm inputting most of the measurements taken before right here. After that, the part is exported as an STL and then loaded into a slicer, and then it's converted to G-code. And later you will see the time-lapse of the print, but I want to tell you a bit about the material used before, because I think that's important. I think ABS is a good material for using in LED lights, because it's quite a high heat environment, and using PLA would obviously lead to melting of said PLA. Same goes for PETG, they are just too close to the glass transition temperature of the material. Of course, you could use other materials like polycarbonate that would be even more heat resistant, but I think it's not necessary for this build, because you try to keep your LED as cold as possible, and keeping it underneath 60 degrees, which is totally fine for ABS, should be your goal. So right from the hot build plate we have the 3D printed parts right now here. This is the main body where all the electronic support components are gonna be fitted into. And right next to it you can see the lid, and in between them there is the hold down for the LED driver that I'm showing you right now. I took it out of its packaging to make it smaller and easier to integrate. This is the Highlink AC to DC converter to supply 5 volts to the fan. And next I'm gonna show you the fan. It's a 5-volt model, of course. Right next to the main body you see an H-shaped part, and that's the clamp that holds on the LED to the heatsink. It's a flexure, so it provides pressure by bending the 3D printed part. Now you can see me highlighting the 700 milliamps again from the LED power supply. And this is the thermal grease. It's just the generic Chinese thermal grease I bought a few years ago. So let's jump right into the assembly. First I'll start by, I call this process training the screw holes. I think it's way easier to screw in screws in 3D printed parts once before you finally mount a part in there. Sometimes space is tight or it's in an awkward angle. So screwing the screw in without the part actually being in there, or without the whole thing mounted, it's way easier, and so you cut the threads into the plastic. If you're wondering which screwdriver I'm using, it's the LTT one. So it's from Linus Tech Tips, and you might think, oh, what the fuck, he spent 70 bucks on a screwdriver. But let me tell you, it's an awesome product. It's just good. So after training of the screw holes is complete, next step is mounting the LED driver, and therefore I'm gonna fit it in here. And actually I designed the hole a little bit too small, or the ABS shrinked. After printing, ABS shrinks a little bit, and I might have compensated a little bit less for that, so I will struggle a bit right here. But after a while of fiddling around, I'm able to mount the hold down bracket right next to the transformer with 2 screws. Okay, next step in line is mounting the 5-volt AC to DC converter that later will drive the fan, and that one just fits into a box that I 3D printed into the case. It's the same mounting mechanism as I've used before, and it's totally sufficient. Because you can't read the text on the top of the component, and it's the one that is normally meant to be soldered onto a circuit board, I'll mark the polarity right now. On the AC side, polarity doesn't play a big role, so that's why the wires on the AC side aren't marked. After a short test fit, I put a roll of duct tape on the bottom of the AC to DC converter and then press it into its hole, so it's nicely secured. Okay, after swiftly removing the terminal clamp from its associated wire, and that enables me now to mount the terminal block to the 3D printed part, also known as the main body of the lamp. And I do that by making sure the screw is screwed in all the way into the terminal block, so that the base of the screw is flush with the one of the block, and then pressing on it while screwing the screw into the 3D printed part. I'm creating the tightest fit possible, because my screw unfortunately is not moving freely through the terminal block. The whole thing is an oversight on my end. I should have picked the smallest screw that would move freely through the terminal block, so it could create pressure with its head on top of the block and clamp that to the 3D printed part. Unfortunately, I made a mistake here, and I designed my hole in M3, and so I need to struggle with it for a second right here. I think it's important to mention these things because these get easily overlooked. Okay, the next step for the build is removing the old wires from the AC to DC converter for the fan, and then taking the length for the new wires. What I mean by that is I will take the length from the terminal block to the AC-DC converter, and then from the terminal block to the LED driver board. After selecting the right length, I'm removing the insulation and then twisting the wires so that they don't fray. The next step is pushing the wires into the LED driver, and here the twisting greatly helps, but a solid core would be better for this application. Because both parts are screwed down, there's no tension on the wire, and I think it's okay in this application. to go with twisted wires into terminal blocks like this. Normally it's not advised though. The next step is to twist one wire of each pair together, and then I'm putting on a ferrule to clamp them together, and I'm using the special pliers provided with the ferrules. After that, I'm inserting the two wire pairs of 2 wires each now into the terminal block, and then I'm tightening the corresponding screws. After tightening the terminals, I'm trying to route the wires as nicely as possible through the 3D printed case, and then I'm soldering them on to the terminals from the AC to DC power supply that drives the fan. After soldering on the wires, I trim the excess solder and wire off to make it nice and neat and to make the lid fit. And that's it. Most of the electronic work is done by now, and we can now start cleaning the copper LED with isopropanol to prepare it for applying the thermal compound. Firstly though, we need to measure out the proper length of wire. I'm using silicone multi-stranded wire here. It's very flexible and nice to work with, and also it has a high heat tolerance. That is an advantage for using it with high power LEDs. Although this one should be cooled nicely. To make my life easier, I'm marking both ends of one cable with a black Sharpie. And I will use the marked wire for the negative polarity. So next you can see me now holding down the cup with my pliers, and I'm wetting the 2 solder pads. After that, I'm soldering on the wires to the cup. The next step is spreading thermal paste on the cop LED, and I do that with a small piece of credit card I cut up. After I have created a nice and even layer of thermal paste, I place the cop LED on the heatsink and wiggle it in place so that the thermal paste can form a good bond between both metals. This also has the advantage that now the LED sticks a bit to the heatsink, and I can continue routing the wires without much problems to the back side. The next step is placing the flexure onto the cop LED, and you can see the aluminum tape that's on there, and that is to reflect the light away from the black ABS plastic. Otherwise it would heat up a lot and probably melt, and therefore no longer press nicely against the LED. After that, I'm inserting the screws into the different screw holes and taping over them to prevent the screws from falling out when I turn the whole thing over to mount the main body or the main 3D printed part. And I'm also taping on the fixture directly, making sure I can easily remove the tape later. Now we come to probably one of the most annoying steps, and that is tightening on the nuts to the corresponding bolts that go through the flexure. This was very difficult because the holes that are designed into the casing are too small, so it was very hard to grab the nuts and also to turn them. The next step is to thread the wire through the case. This worked quite well. Once the wires went through the opening, I applied solder to the tips of the wires. Because they are very finely stranded, it is not feasible or possible to push them into the push connectors from the LED driver. So solder is the right solution, I think. Normally you shouldn't put solder on wires that you clamp, but because it's a dynamic clamp with a spring basically, I think it's okay to use solder in that case. If you have a solid connection and solder on your wire, the solder tends to creep away under stress, and that can lead to a high impedance connection, and that's a bit dangerous. So after making everything nice and tidy, we come to the next thing, and that's the fan installation. For that, the first thing you need to do is to cut the connector from the fan, otherwise it will not fit through the bottom holes in the case. And there's also no receiver for that connector in the case. Then is trimming the length of the wires so that they can barely reach the AC/DC power supply. And with that you can also strip the insulation and apply solder to the wires, and then solder them to the AC/DC power supply. This step though is sensitive for polarity, so keep that in mind. After the fan is soldered on, you don't want to have it flapping around in the breeze, so now's the time to get it connected solidly, and I do that quite crudely, I'd say, by just screwing the fan with basically small wood screws directly into the aluminum of the heatsink, and it spreads the fins a bit of the heatsink, but it shouldn't hurt the performance at all, and the fan is nicely secured that way. And with that we basically have only one more step left, and that is to connect the mains wiring, or the wire that will later connect to the IoT switch that I have the lamp connected to. And that works as follows. Firstly, as always, threading the wire through the case from the bottom side, and then connecting it to the terminal block. This step is not polarity sensitive, so keep that in mind. Off camera I routed the cable a little bit and connected it with some cable ties to the back of the lamp. But overall that's everything, and I just need to put on the lid and then it's finished. So next you're gonna see the installed lamp shining in the greenhouse. And also a thermal profile, so I'm gonna go over the whole installation with my thermal camera. And as promised, here we have the image from the thermal camera. To give you the ballpark numbers, the room temp was about 20 degrees C, and the light was running for longer than, let's say 20 minutes. So thermals should have equalized at this point. The hottest part on the LED chip or on the COP itself was something like 46 degrees, and that is making it the least warm of the main components, I'd say. The second spot goes to the ball bearing on the fan. It's a sleeved fan and it's running not vertical but horizontally, so it's not so nice for the bearing and therefore it's warmer. And the hottest part is the main transformer from the LED driver, and that's at 70 degrees-ish. So all these parts are well in their thermal envelopes and the light should last for quite a long time. So this is filmed about a week after finishing the light, so we had a brief run-in period. And as you can see, it's performing nicely. The color temperature is actually very good. The pots look nice. Oranges and red are sometimes harder to replicate with LED light sources, but they look great here. And also with that, the plants look beautiful. And they are a bit unhealthy, but that's not due to the light source, but rather to insects or pests that were living on those plants before. It's a great environment to keep them and to get them stronger. Under the high intensity light, everything grows much better. Also, the humidity level in the greenhouse are controlled by a humidifier in the corner and a sensor up there. So, and that's basically how I'm gonna leave you here. Thank you for watching, and I hope you liked the video. If you really enjoyed it, you can give me a thumbs up or even comment. And if I get a few comments about the humidifier, I might make a video about that. Also, if there's sufficient interest, I can upload all the files on MakerWorld or on the browser pendant to that. So have a nice day and thank you again for watching.